Question 8a, part 1. We need to write down the acceleration of the particle when t equals 5. So when t equals 5, well, the acceleration is just 0 meters per second squared. And the reason is, well, on a velocity time graph, the acceleration at a particular point is just equal to the gradient of the curve, or gradient of the line at that point. So when t equals 5, be, say, that point there, well, the gradient of the line is just 0, so hence our acceleration is 0. So that just means, as you can see, we're going at a constant velocity. From t equals 2 seconds to t equals 6 seconds, well, our velocity is always just 10 meters per second. So our velocity is not changing, and hence our acceleration is equal to 0. For part 2, we need to find the distance travelled by the particle p between t equals 0 and t equals 10. So we've got our velocity time graph here, and the distance travelled is just going to be the area under the graph. So you could cut it up into various shapes to help you, like maybe some triangles somewhere, and a rectangle, and a trapezium. I'm just going to make 2 trapeziums to make it easy. So this one here, I'll call this one trapezium A, and if I make a line down here, we'll call this one trapezium B. So our distance travelled then, well, it's going to be the area of A plus the area of B. So the area for trapezium A, well, we've got our lengths. This is 6, and this length up here, that's going to be 6 minus 2 is 4. So the area for that one then is going to be half of 6 plus 4 times our height, and our vertical height is up here, is just 10. So we're going to multiply that by 10. And then we need to add on the area of B. So our lengths for B, well, this one here is 10, that's one length, and the other length, highlighting in yellow here, is going to be 20. And our vertical height, well, that's this part through here, which is 10 minus 6 is equal to 4. So for area of B then, it's going to be half of 10 plus 20 times 4. So working this out, it's going to equal half of, well, 6 plus 4 is 10, and 10 times 10 is 100. So half of 100 is 50. And then the second part there, half of 10 plus 20. So 10 plus 20 is 30. Divided by 2 is 15. And then 15 times 4 is 60. So that is equal to 110, and we'll put our units in meters. Okay, so that's question 8a. Question 8b, part 1, told this particle q has velocity 3 times sine 2t minus 1, and we need to find the speed of q when t is equal to 7 pi over 12. So we'll just plug 7 pi over 12 into our equation there. So that means the velocity is going to equal 3 times sine 2 times, or 7 pi over 12 minus 1, and that is equal to, well, 3 times sine, and all 2 will cancel with the 12, and we'll be left with 6. So that's going to be 7 pi over 6 minus 1. And, well, sine of 7 pi over 6, that's going to be in the third quadrant, so sine is going to be negative, and sine of 7 pi over 6 is negative a half. So you could also just work that out on your calculator. So if I bring up the calculator, just make sure we're in radians mode. So we just want sine of 7 pi over 6, and that is going to equal negative a half. So now we're going to get 3 times negative a half minus 1, so that's negative 3 over 2 minus 1, and so that is equal negative 5 over 2, which is negative 2.5. Okay, and we can put our units in if we want, so that's meters per second. So that is 8b part 1. For part 2, we need to find the least value for t, for which the acceleration of q is 0. So the acceleration is equal to the derivative of the velocity. So we were given the velocity in part 1, which was 3 sine 2t minus 1. So we'll take the derivative of that with respect to t. That will be our acceleration, and then we can set that equal to 0 and then solve for t. So we get then dv by dt, that is equal to our acceleration as a function of time, which is equal to, so the derivative of 3 sine 2t, we're going to need to use the chain rule here. So the 3 is constant, so we'll leave that there. And then, well, the derivative of sine of theta is just cos of theta. So sine of 2t will become cos of 2t. And then we just need to multiply by the derivative of our inside function, which is that 2t there. So the derivative of 2t with respect to t is just 2. So we will multiply by 2. And then the negative 1 is just a constant term. So that just goes to 0. So now we get our acceleration. That's going to be equal to 6 cos of 2t. And now we just need to set this equal to 0 and solve for t. So we have then 6 cos of 2t is equal to 0, and that implies then that cos of 2t is equal to 0. So if we have cos of an angle, cos of theta equals 0, well, that angle, theta, that must be pi over 2, 3 pi over 2, 5 pi over 2, etc. And, well, I'm not worrying about the negative values of the angle because we're just dealing with time here, and that is always going to be greater than or equal to 0. So therefore then, we're going to get 2t is going to be equal to pi over 2, 3 pi over 2, 5 pi over 2, etc. So we want the least value for t, so that's going to be this one here, this pi over 2. So therefore then we get 2t is going to be equal to pi over 2, and that means then that t is equal to pi over 4, and we can put the unit seconds. Okay, so that is question 8.